All right, welcome back to the COFF file generator project. It's been going for a while now, but we are making lots of good progress. And if you'd like to see the progress keep coming, keep in mind I am counting on people who see these things and appreciate what I'm working on and who want to see it succeed. Coming over here to mrforth.com/membership and considering becoming a member or a supporter. There's a couple different price points and ways you can do that. You can also just do it once and cancel if that's all you can afford. I understand. But there's some cool perks, and it helps a lot. It's what I'm counting on so that we can keep a project like this going without having to modify the project for, the interests of some larger, wealthier patron, which I'd like to avoid. So today, what I want to work on is yesterday I was building a new feature on top of the block system, and it turned out really great. It felt like the block system was exactly the right tool for the job 80% of the time, but there were some little issues, some wrinkles, and we made some notes about what to improve about the block system. So the block system feels like the right system, but there are some rough edges on it. And so today I'd like to start by smoothing out some rough edges on the block system. And if that works out and we get done early, we can get on with building more features. But first, I'd like to try to work on that. And so there are two main ones that I think we can do today that are worthwhile. And the reason they're worthwhile is they are semantic. So these two up here are semantic issues. The two down here are acceleration issues. I could So these two are more semantic. This one is going to take some consideration. This one's just a feature that we need to add. But I can't just go and hack this feature in without considering this first, because they might also relate to one another somehow. So let me go draw some pictures. I might be quiet, but if there are questions, I will answer them. But I need just some time to explore some questions with a picture for myself, just to understand this this problem. I will explain the problem a little bit, if I can. Let's see, rearranging for heavy drawing time. Okay. So we're dealing with we have these blocks, and each block is technically actually a sequence of bytes. 1, 2, 3, 4, 5, 6. Perfect. Block. And so each one sort of has an address. So this might be address number 100 and 101, 102, 103, 104. So these are like addresses. These are the pointers. Or I'm just going to say addresses. Here's the memory. Here are the addresses. 104, 105, 106, 107, 108, 109, 110, 111, right? And so those are the addresses. And then what happens is we have offsets as well. So this is offset 0 in its own block. 1, 2, 3, 4, 5. And this over here is offset 6, 7. Oh, whoops. This over here is offset 0, 1, 2, 3, 4, 5, right? Hey Tool, I've been having a good day. Hope you've been having a good day too. So if I allocate 2 of these blocks and they're abutting like this, so address 105 at the end of this block, address 106 at the beginning of this block, then if I were to ask, hey, I've got a pointer here. I have a couple of maps I need to be able to implement. Let's switch colors here. Let's grab our, we need a couple of maps. We need to be able to map a pointer or an address to a block and offset sometimes, right? So the question mark here says, you know, if I gave you the address 50, well, there is no address 50, right? We have a unique address for each byte we've allocated, but not every byte that could be allocated in the whole program is inside of a block, so this map doesn't cover all possible addresses, right? And the other one we want to be able to do is we want to be able to take a block and offset and map that to an address. Now that is guaranteed to work so long as the offset is within the block's valid range, right? So like if you put in, the question is like if I wanted to, right, map 106, let's name our block. So this will be block A, and this will be block B. Then what we have is that address 106 should map to B0. Address 105 should map to A5, and so on, right? And as I'm looking at this, I guess like that technically means there are invalid block and offset combos. It's just easier if I mark it that way. Right, I can put A6 together and that should just give me nothing, I guess. So the problem is sometimes it's convenient to be able to talk about one past the last on a range, especially with pointers. Like if I allocated an array of 3 elements with 2-byte entries, right? If this was 1, 2, 3 entries, then a pointer to right here can be very meaningful. And being able to take the address of that whole array plus one past the end of that address, and then I say, hey, give me the block and offset for one past the end, feels very useful. And so if I were going to do that, I would run into this problem where 106 could also validly map to A6, right? Now, if we happen to take block A and block B and arrange them into a new block where they abutted, then having these two things both be options would be fine. We would make A6 and B0 equivalent by chaining them together. So that is possible, but it's not guaranteed to happen. It could be B comes before A when we go to arrange the data. It could be that there's things in between them that they're not even touching. So we can't just say, well, since they both say 106, then this equals this, right? And 106 has to be able to refer to this because that's how we get it for writing a byte there. So the options I can think of are blocks. A block and offset is always valid if it's less than the size, but you can't do one pass last. But if we wanted to support one pass last, that's what we're trying to do here basically. If we want to support one pass last, what we could do is we could say is that how you spell a butt? I forget how you spell a butt. Yeah, okay. They must never abut. Okay. So, I think there's an easy fix. Let's just explore this idea and see if something bad pops out. When we allocate block A, so block A size equals 6, we'll go 1, 2, 3, 4. I hate this. One, 2, 3, 4, 5, 6, and then we'll put in a little killer right there, right? And so now we're looking at addresses like 100, 101, 102, 103, 104, 105, 106. And so that's block A now, and block B would hang out over here. Again, a size of 6. And even if they continue right afterwards, there's still a distinction. I'm too zoomed out for these address numbers. Right, so now we have 106 maps with there we go. 106 maps with A6 a 1 past last index, and 107 maps with B0. Now later I might make A6 and B0 the same thing, as in when they map to a larger block and they're budding in that larger block, then then they will both stand for the same offset into a larger block. But we don't guarantee that blocks are contiguous when they are chained together, right? So adding in this padding here doesn't break any of the other assumptions that our system makes. So the valid block off is based on block is a valid block and the offset is inside the range 0, the size, the block size inclusive. Cool. Yeah, I don't see any reason why that wouldn't work. Now the other thing we want to think about, let's stop there, grab our red and block this off. The other thing we want to think about is the alignment question. Sometimes I have a block, A, it's got some size, and we want to be able to say something like must be 8-byte aligned. So that first byte has to be 8-byte aligned. Then once you have that, you have things like that's 8-byte aligned. You know that this, if this keeps going, is 8-byte aligned. So everything you do after that, if you have a base alignment of 8, you have a base alignment of 8, then everything else that you've aligned, like if you filled in this much data and then you did padding here, right? If this right here is real data and then padding, to make our padding look good. All right, and then padding. And then you have something new going on here that goes on. I'll just dot that. We get it. There's more that goes on and on and on. Then that guarantees right? So we have this set up here, and then the question is, what happens if block A gets put onto a chain? So we have, let's make this our block L, and it contains a chain of blocks. Block B, block C, right? And then we want to say, let's add block A into the chain. Block A. Right? Now, here we have some total size before we try to attach it to the chain. And so we may want to say, okay, while attaching A, add necessary padding. Right, so we could just say, like, insert a little padding guy here. That's one option. Another option is that we don't actually explicitly do this. We just say, hey, whenever we're going along figuring out the total sizes, we're going to say, like, here's the total size of this, and then when we do block A, we're going to go, well, the total size of block L is added up as, so this is, let me mark this. This would be an explicit solution. But there's kind of an implicit solution, which would be, here's our block L, right? We have our block B, we have our block C, we have block A coming in. Okay, so the implicit solution is that the total size of something like block L is computed as it's not just the sum of the total sizes of each block. Block B, so we need to do the total size of block B aligned to the alignment of block C. So there's the sum well, let's just spell out each one. So this is the align total size of block B and align it to the alignment of block C. So that gives us the starting point of block C, and then we do the align again the total size of block C to the alignment of block A, right? And then finally we do the total size of block A. right? So it's basically the same rules as struct layout. You put this down at the beginning, then you look at what your next alignment is, and you add in whatever padding you need by aligning up to that alignment. You put down the size of this, and then you add in alignment, and so on and so on. And so then, when we are adding in block A, how would we do it? Well, we would already have... Let's back this up. Before we add in block A, the total size would be written like this. That plus total size block C. Right, so that gives us... This is what it looks like before attaching block A. And I guess the question is, can I take this as it is, as a final, a fixed expression, and not insert something here? Because the way I wrote it before, I would need to pick apart the total size of C from the rest. I suppose I could look at the final block, subtract the total size of C, and then round it up and add it back in. But I guess I'm wondering, like, wouldn't it be the same to just align the whole thing? Actually, if this has an alignment of 4, say block C has an alignment of 4, and then block A has an alignment of 8, then I think it would be necessary to align the whole thing, because the alignment of this to a boundary of 8 with plus the alignment of this to a boundary of 4 wouldn't get you there anyways. So then after attaching let's call this size 1, and then after attaching block A, we would have that the total size of block L is the alignment of size 1 to the alignment value of block A plus the total size of block A. Right? So we could update total sizes that way. We would also have either way, so that's the implicit solution. Requires less small nodes in the block system. Either way, we're also going to need the property that the alignment of block L needs to be equal to the maximum alignment of all of its children. So the align of block L is equal to the max, and let's say as C goes over the children of L, the alignment, damn. The alignment of block L is the max of the alignment of all of the children, right? So that's something we need. What else do we need? Total sizes, chaining, alignment propagates up. Finally, there's figuring out the offsets, and this would need to be done more carefully. So this right here leads to two things that are a little trickier. We need careful calculating offsets, and we want to be more careful when we're flattening the data. I think it would still work though. I think it'd be relatively reasonable. Okay. All right. I think I've got some clear pictures of what I'm doing. Let's get this set up back into keyboard mode. I don't see any reason why those two things shouldn't just work independently when I think about it. So I'm gonna just put on some nice Friday kind of jamming, kind of low-key music, a little bit of a blend. Let's try these things out. Keep those on 8-byte alignments in the arena itself. So I think with that, we have the ability to do one past last pointers. Okay, here's an interesting problem. If we use this implicit approach right here, then we can't actually finish this mapping, right? This mapping we were building between valid block offsets and addresses. If there's a block and offset that, say I've got a list. Yeah, say I've got my list, and say there's padding that's right here, but it's implicit, so there's no actual data allocated for it. Then if I were to give you block L and an offset to this part of the block, I wouldn't be able to convert that into a pointer. Even though it's a valid section of the block. So maybe I should write that in here. Seems like a big deal. I think that might be a non-starter as I think about it. Okay, well, that's interesting. There are things I could do, like say hey, we have a null buffer that's sitting around and is read only, and so it's just it always points to that. And if you try to write to it, it'll give you an error like, hey, you're filling in padding bytes, but that assumes that the padding is always going to be nulls, which I realize might not be true either. Sometimes having a fill byte is nice. Although that might need to be explicitly pushed instead of implicitly set up by the blocks. I don't know. That's an interesting question too. I'm gonna take a quick break to get my head a reset now that this little thing has thrown me. And when I come back, we will pick a path and keep going, because I'm not quite sure off the top of my head which one I want to do. It's a little early for a break, but I think since I've just hit this random issue, that a little break might be good. So I will be back. Let me do it this way. I've been doing it this way recently. All right, I'll be right back. Okay. So, I've been thinking, and I think we got to do it this way. I think it's just going to be a lot easier because it's just going to automatically work. We don't have to do this thing. We don't have to worry about this thing. We don't have to worry about this or this. We still have to do this part, but you know, these two things still very achievable. So let's do it that way. Okay, so that's how we align things now. Now, when we push a block onto a list, a few things have to happen. The list's base alignment needs to become at least as big as the block's base alignment. we're going to align by pushing onto the current list, using the list's current padding fill byte, and using the base alignment from the block. So if the block's asking for an alignment of 4, then this just makes sure that we are now aligned to 4 on this list, and then it also makes sure that the list knows that its base alignment needs to be a 4. Everything still works. I think that's it for those two things. I do have some to-do sitting around. Yeah, so the block IAT needs to initially align to 8, and the block import lookup table also needs to align to 8. Okay, I think we had talked about before, if I had not done this, and I just left it the way it had been, and then I made an imports list with 2 tables, like this. Then I think if we generate it, it's going to fail to load. But does it align or misalign? Right there, C42000, this is misaligned. It's on an alignment of 4. You see that? It's on the 4 instead of a 0 or 8. The first one's aligned fine because it's the beginning of the section, but the second one, since we have 2 of these, we have generated DLL here. No, not that part. We have, yeah, we have 2 different imports happening here, right? So generated DLL ends there, operate ends there, and then lookup table RVA. 1, 2, 3, 4, 5 of these. 1, 2, 3, 4, 5 of these, and then the nulls go there, and then finally we have this aligned at a 4. Now if I switch to the new system and I generate it, I reload, and I reparse, there it is aligned to an 8. Cool. It's good enough for me. So that's it for the block system semantic improvements. Alright, with that, we still have a good hour to work on stuff. So let's check out one of these problems. Importing KERNEL32.DLL is not hard. The only hard part involved at all is well, let's see. I'm going to drop my exports list. We're going to switch over to making an exe now. We're going to switch to KERNEL32.DLL. We're going to load. Let's see. I want to open animation exe. I want to look at the import table. I'm sure somewhere in here we're going to find KERNEL32. I'm not sure where we'll find it. Can we jump to this? Yeah. Here's our import directories. Here's all the name RVA things. WinMM, username, advanced API. at system time. Virtual alloc. Okay, it would be cool to be able to call virtual alloc. One sec, I better check that. Seems like a lot. So all of that. Let's look at virtual alloc 14976. Okay. Is that the idea? One 1497. I don't know where I got the 6 from. 1497. And then virtual free 1500. All right, let's see if I can do that. And then let's see, what else do we need? Text block. Yeah, obviously I'm going to need to rewrite this to, say, call virtual alloc. And then do something interesting here. So we'll do that this way. We don't need any exports. No data section. Just pull that out. No exports. No exports. No base relocations. Generated exe. Thanks for the heads up. Hopefully that's better. Very good. And we need to rewrite this part too. This is where it's going to let us call virtual alloc. But let's turn off these for a minute. I'm going to work on mini .asm. I think the kernel linking is going to happen automatically, I believe. Let's hope. I could also do it this way. Okay, we'll see. We'll see. Okay, so to call virtual alloc, what is the setup? We have 1, 2, 3, 4. Okay. Yeah, give me my ABI conventions. RCX, RDX, okay. There's 4K, 8K, 1632. Every time we do, okay, here's 4. If I add in 4 bits, I'm multiplying it by 16. So 2 or 4K. If I add in 4 bits, each bit is times 2, times 2, times 2, times 2. Yeah, it's times 16. So this should take us from 4K to 64K. 4 of those is 256K. Let's write it this way. 4, 8, 12, 16, 20. Okay. 2 to the 20 is a megabyte. So that's how much we're going to reserve. Allocation type. Okay. 3000. Read write is 4. Execute read write is 4. Okay. So weird how these are set up like flags, but they actually are exclusive. Cool. So afterwards, RAX would contain a pointer. So we could do something like mov into RAX 111H, right? Keyword putter 1, 2, 3, 4, 5, 6, 7, 8, something like that, right? That could be done. I don't know. One, 2, 1, 3, 1, 2, 1, 4. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Okay. Now I have to convince it that it actually does have everything it needs to link. It can't move that into, right, a memory address, so we got to move it into a register and then move the register into the memory address. Very good. So that generated a DLL called mini. If I want to, I can go over to my test load gen. Could load in mini, could load in operate. The type is now this. Don't know why the generator is suddenly failing, but that doesn't matter. The more important point is what's the run function right now? That's run the generator. Okay, what's the project function for running the test load? That's F5. That looks bad. Okay. Let us work with remedy here. Okay, we're in the we're in the right place. Pull in mini DLL successfully. Pull in operate successfully. Calling into operate. RAX should now contain a pointer. RCX gets this. We try to write that into RAX. That succeeds. We return. And it's garbagey. Oh, the stack. There's our pointer. There's our operate function. Oops. Let's have test load gen. Instead of using LLUs, let's have it use LLXs. Let's have each %LLX look like this. What's going on here? Oh, the build file. There we go. That all looks good to me. So now I'm going to go look at mini DLL in the hex editor because I want to steal its text section. Okay. But I actually want my main if I'm really trying to generate an EXE, let's not generate an EXE, let's just generate a DLL. It's going to make things easier. Good. Now generate text section. This is where we need to use remedy for help 2. Show code bytes. 4 for the sub RSP. 7 for the mauve. Seven again for the next mauve. Seven again for the next mauve. Seven again for the next mauve. Is that right? C7? No. 0, 2, 4, 8, C7, C1, 0, 0, 0, C1. Oh, these are only 6 at a time. Whoops, okay. Four, 8, 08. Okay, what did I miss? 08, 488908. But C3 doesn't happen until here, so what is this? What is this? Oh, right, this is add RSP. How did I miss it? Oh, it must not be showing up over here because I never... Yeah, that makes sense. Okay. Right. Now this part right here is the added jump. To RIP plus the address of IAT0. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 24, 31, 38, 39, 43, 53, 56, 57, 58, 59, 60, 61, 62, 63, 64. Okay. So the spot at 64 is a 32-bit relative offset with a -4 bias that needs to point to the IAT slot. Okay. Now why are we crashing? That we didn't actually look at yet. Okay, my count must be off. I'm going to start from right here. We're going to take a look at the text block. And we're trying to figure out where the offset is for those last 4 zeros. Looks like the offset is 63. Got to set up my exports again. So let's see if I know how to use the API now. I believe it is 6. We're going to export the operate function at this address. Except we still need to do these, I believe. Okay. Oh, you know what? I made the export table. Like, I made the export list here, but I did not bake it and put it into the RData section. Let's try to do that. Exports needs the patch list and the exports table. Data directory. There we go. All right, so I can import kernel32.DLL. That's no problem. It's not special. It's not different. All right. What about C runtime? We got a little bit more time. Let's try it out. Let's see if it's doable. So let's do the same thing we've been doing. We go over to this. We switch off of the generator. We're gonna load these up again. Test load gen is gonna switch over to mini. Miniasm is gonna switch over to what's a good C runtime symbol to try. So like I think the fun one would be printf. The hard thing is that it's variadic function, which is new. Maybe fwrite instead. Trying to think of some way to just put some output. We're close to like having a hello world type situation, right? And so I want to try to get there. Let's see, call fwrite. What is the signature for fwrite? Buffer size count stream. All right. For buffer, we're not sure what to do yet. We got to figure out how to add some data to our program again. For count, it's going to be the size of that. For size of element, oh, that'll be a 1. That'll be this count right there. And here we need to figure out how to get our hands on standard out. So unfortunately, there's no standard symbol name. which is great. It's never gonna say. So what I need to probably do is we're gonna back off by one step. Before we do F-write, we're just gonna do malloc. Malloc is a lot easier. We're gonna say, please malloc me, I don't know, 4K. One, two, three, 4, 5, 6, 7, 8. Keyword putter. So very much like what we had before. We're going to allocate some memory, fill the first 8 bytes, return it. Now let's see, how are we going to get it to link malloc? Let's try this. Okay, so to actually build that, you probably need something like one core.lib, I guess. that coming from? Well, I'm not running the compiler, I'm running the linker. There's another approach I can take here, which is to take out the no default lib part, but that's gonna suck since it's gonna now grab all the default libs. It still doesn't find malloc anyway. Give me all the default libs and libucrt. How about that? That doesn't help. Oh, okay. Let's go and look at the linker options. Maybe yeah, so I see there is a flag for turning this off in the compiler, but I'm dealing with code. I'm trying to link against code that I can't rebuild, which is this C runtime that I got right here. Now that might not be the right C runtime. What I would love to do, I would really love it if I could just do this. But it doesn't actually find malloc that way either. But this here does seem to actually pull in a malloc implementation. Okay, let me see if I can understand what you're saying. What if instead of using libucrt, we just use ucrt.lib? Is that the idea? There it is. Okay, so that's cool, except now the C runtime library has to be in the path, so I can't statically link the CRT, which I prefer to do. But if I can do that, so that's working. It looks like these are full of garbage. Does malloc not clear to 0? Okay. Okay, so that's cool. UCRT.lib does in fact work because this one tells it to load the DLL version, and the DLL version already knows how to load everything else. But I do want to learn how to statically link this. So, it starts with this. We get unresolved symbol imp heap alloc. That is, I believe, solved if we just go, where does heap alloc come from? Pretty sure it comes from onecore.lib. KERNEL32.lib. Let's try that. Okay. 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 So there was another approach that was working earlier. If I did onecore.lib, then I got security cookie, GS handler check, guard dispatch, check stack, unresolved mem copy mem set. Okay, so where are all those? Those should be with the basic thing. Well, let's see. list me all the default libraries somewhere. Why don't you do that? Cool. Okay. Let's take some steps back here. If I use this, and then I go dash verbose, what do you give me? Brilliant. Okay. Okay, that's the verbose option. This literally doesn't include anything. These seem maybe like what I want to look at. Alright, the first one is like this. What do you have? It's more than one. Right. Okay. One at a time then. 1. 2. 3. Okay. Interesting. How far back do I need to go? Let's try to here. 10 lib 10.0.19.04.1.0 x64. Okay, don't know why you couldn't find this, but there we go. Okay, so we got 1, 2, 3, 4 paths. You could totally be right. These might be the missing pieces. Let's try this. Thanks for the tip. Let's do libucrt. Build that. Let's turn off verbose. And then libvcruntime.lib. Okay. And the native CRT startup. Hey, that's all of them. libucrt.lib, libvcruntime.lib, libcmt.lib. Look at that. It says them right there. Okay. Okay, so this version works. this version builds, but it doesn't work. Right, if I build this way and then I hit F5, I get procedure load failed. Why can't you open libucrt now? Ah, good point. No need for the comma. It crashes. Okay, now let's figure out why. So test load gen, step in, we load the operate function, so that worked. We step into operate. We try to call so this should have jumped us to here. This should have jumped us to here. This jumps us to here. Wish Remedy could step through the assembly a little better. Like, watch this. If I jump to here and then I go step into the call, that's good. If I want to step over this, what do? Well, I can go step over instruction, step into instruction. There we go. Step. So this spot, run to here, step in. I don't have any keys for this, but step into that. Step into that. Step into that. RBX. So I think what must be happening is that the CRT init hasn't happened, and that's causing a problem. There we go. So if we do this, it's fine. because we're loading the DLL, we're loading it as dynamically, so the CRT in it gets to happen. But if we do it like this, then it's not fine because CRT in it gets skipped. And so we have to not manhandle the entry point and let the entry point be set by the CRT, and then it calls our main for us. Like it sets up the CRT main now, right? Another way we could see is if we took this out, it would tell us DLL main CRT startup. And I wonder which of these three is the one that provides that. It's not that one. It's not that one. It's that one. Okay, so if I link all of these and I set the entry point to my main, and then I call DLL startup, and I have an extern by that name hanging out, what happens? It works. It builds and it doesn't run. It still doesn't run. I don't understand. I don't understand that. Not that it's that critical. Like, I don't actually need to be able to control the main. I'm just curious. What's the difference? Stack will be unaligned after call to DLL main. Interesting. What do you, I'm not sure I know what you mean by that. What do you mean I have to align the stack before calling? I haven't done a lot of the CRT manhandling kind of work before, so. I mean, like, if you're talking about, maybe I need to do this stuff? Like, do I need to set up a frame? I'd find that a little surprising, I guess. So what's the deal with 16 bytes? Why is that special? Wait, really? The ABI says that the stack frame is supposed to be 16 byte aligned? I don't think I've ever known that. I've definitely done tons of calls that don't bother to check or support that. But maybe DLL main depends on it? No. So I think it works better if I do at least this much. Maybe I need to do that much plus extra if your idea is right. Hey, there it is. Okay. Yeah, no, so it needs the full shadow block, which is the 20H, and it needs the 8H for the alignment, seems like. And I guess like if we did 28, if we did 3, it would not be 30, it would not be aligned. So that would fail. But if we did 3-8, it should be aligned and big enough to handle the shadow block, so it would succeed. Okay. Okay. Accumulator says I should align to 16 bytes with an AND. That's interesting. I don't know if I've ever seen anything like that. If I do an AND, does it actually work as a prologue? Just curious. Microsoft function prologue. Thank you. Okay. Okay. Cool. I see that. What is this? And this is ABI conventions. Cool. Awesome. Well, thanks for the link. Definitely gonna check it out. I'm trying to figure out how I will use the idea of forcing you to align the stack pointer during the prologue if I also want to be able to mark up this stack unwinding correctly. Yeah, I'm just looking at the suggestion from Cumulator, which was to and RSP, and I just don't see any way to do that and mark it. That seems like you would lose the ability to unwind if you did that. Like you're forcing alignment. How do you recall your alignment? I guess the only way you could do it would be if you use a frame pointer. But I think we have to assume that whenever we get called, we must be 8-byte aligned, right? Like the only time, there must always be an 8-byte alignment during the prologue at the beginning because... Right. If I'm guaranteed that I get called 16-byte aligned, the thing that's confusing to me is, obviously I'm not guaranteed to be 16-byte aligned. I'm guaranteed to be 16-byte aligned plus 8. So I always have to do at least a plus 8, and then a plus 2 8, like this, if I need the shadow box, or if I want to like push stuff on the stack here, I have to count how many things I pushed and make sure I get one extra plus 8 by the end. Cool. Okay. So if that's the case, it's good to know that. I'm not sure where to write that down or where to put that information yet. ABI is not a part of the plan yet. But we can do a few things. We can make sure to do this correctly everywhere. And of course I don't have to do this because I can just let it call DLL main directly, and that works too. So with that, I think we did it. We can now import C runtime. Let's make one more to do here, which is we've got basic C runtime working. We still want to be able to call F right? And then printf. We want to learn how to do those kinds of things, but we're getting farther and farther into like C runtime specific stuff, ABI specific stuff. So I don't think that this is helping us with generating. This is all just basically running off of import tables. Like, okay, so here's the main thing. Actually. Let's back up. So I got this working with ASM, but let's, or MASM, but let's take note here. We have not actually done this with a generator yet. So we have this working. Test load gen works on mini. We swap in the generator here. And then we get back to this. So the next step is still to actually get generated DLL to do the same thing. If we were to pop in over here, we don't need this stuff anymore. And reload these things. Mini DLL, we don't need you. versus generated DLL. It's probably a bunch. Yep. DLL is tiny. Generated DLL is tiny. Mini DLL is now big because we're linking in CRT. I'm curious how big it is. Sections, text, R data, P data. It's still 512 bytes for each, so it's not like, I mean, it's not small anymore, that's for sure. Are we sure that it, hold on. Let me make sure it reran. There we go. Well, the main thing, accumulator, that I'm not sure about is like, is it possible to specify the unwind information that goes with that trick? Is it just a matter of saying like you're always going to use a stack pointer when you do that, or a frame pointer when you do that? That's the only idea I can think of. Anyway. What actually happens is once we link in all those libs, all those library files, they plopped in a bunch of import information, right? KERNEL32.DLL ended up in here. But the rest is all statically compiled CRT stuff. Interesting. Okay. Okay. So I think I need to figure out more about what it's going to mean to have C runtime in the mix. When C runtime is in the mix with the linker, it is actually building a text section with all that code built in, right? So all the code from the C runtime is there. The only trick is making sure we are ready to import that. So this is more of a linker problem, actually, not a generator problem. And I might need to back off of this direction for now. Let's go over here to the main list of projects. So I think the next thing we should do is to try to get to unwind information. So that'll be the plan for next time. Thanks for the resources today, Big Fox. I am gonna wrap up. So with this, I'm happy with everything we've gotten done today. It's looking like we are headed towards some new big format stuff that I've never touched before. The unwind information. Not that I've never touched it, but I haven't touched in this pass. I don't have unwind information dumping. I don't have unwind information parsing over here. So we're going to get to that shortly. You know, within the next within the next week. But today's the end of the week, so we are going to do that next week. I am, as always, going to remind you that this project is my full-time job, and I am counting on anyone who thinks that what I'm doing is worthwhile and should keep happening to consider going to mrforth.com/membership and seeing if you might be up for contributing to keeping this stuff going. So with that, I am going to sign off for the day, and I'll see you all around the internet. Bye.